affordability now has become a process for people to understand all of those cost elements and break them down into ways so we can design the products in an affordable way that makes it useful and procurable, if you want to use that as a word, by the consumer.
Welcome back, everybody. My name is Amy Conaway. I'm here with Dave Bice. He is a retired engineer and program manager. Today we're going to be talking about everybody's favorite topic, affordability. And what can you tell us about affordability and what's your insight on that?
Well, affordability is probably one of the more newer tools that are being applied to program management. And it's really one that makes engineers uncomfortable.
How is it a tool?
So affordability is about understanding the cost of our product and versus the price that a customer is willing to pay.
I understand.
So it's really important to understand if we're designing a product that is so expensive, let's say a coffee cup as an example, and it's going to cost $1 million, just to make it absurd, to design that coffee cup and build a coffee cup.
Okay.
No one's going to be willing to pay $1 million for a coffee cup.
Right.
And so designing $1 million coffee cup is useless. You might as well not even start.
That's why they don't exist.
So that's why they don't exist, exactly. So when you're designing your product, you need to have an understanding of how much is it going to cost versus how much is the customer willing to pay. And so
how much is it going to cost to make?
To make,
okay.
Yes. How much is it going to cost? Well, to make and to operate.
Okay.
So you don't want to just think about the cost to make. You also want to think about the cost to sustain it, to maintain it, to operate it. All of those things are important to consider when you're evaluating the cost of the product. And it's really the cost, not just to yourself as a manufacturer, but also to the consumer.
Sure.
And so when you buy a car, how expensive is it going to be to purchase, and how expensive is it going to be maintaining it?
Mm-hmm.
All of that has to be considered.
So that's a big thing with buying foreign cars or luxury cars is, yeah, I can afford that car, but the maintenance on it, it's a couple $100 to change the oil, and that stops a lot of people.
Exactly.
Right. That makes it no longer worth it for them.
Right. And that's another aspect, like electric cars. When they first came out, how am I going to recharge it? How much is it going to cost for me to recharge? And where would I recharge it? All of those things need to be considered.
Absolutely.
When you're designing your product. And you need to do the same thing with anything that you do. Whether it's an airplane, an automobile. And affordability now has become a process for people to understand all of those cost elements and break them down into ways so we can design the products in an affordable way that makes it useful and procurable, if you want to use that as a word, by the consumer. So
there's a lot of balance that goes into
yes,
taking affordability into consideration.
And the design. So historically, design teams have never really considered cost as a product or as a real requirement. It was really more of just a byproduct, if you will. So you would design a product, and then you would go manufacture it, and then you start adding up all the costs and saying, oh, this is how much it costs. And then you would tack on some profit and try to sell it for that. And then you'd find out after you did all that work that no one was willing to pay that price for that product. So you want to think ahead and do some research, create customer user groups or surrogate groups to find out who is willing to pay this amount of money for this particular product. And then once you have an idea as to how much the cost that the consumer is willing to pay, you want to break down that cost into the sub-elements. How much for maintenance, how much for the actual procurement of the product. Mm-hmm. And then when you have the procurement of the product, break that down into each of the sub-elements. So like on an airplane, we'll how much will the engine cost, how much will the wing, how much will the fuselage, the tail, all of those pieces, you want to break those down into their subcomponents and add that up so you understand the total impact.
Understood. I have a question. I want to back up a little bit. You mentioned surrogate customers.
Yes.
If if startup companies are looking to kind of get into that, how would they acquire a surrogate customer? What is the process for that? What is that?
Well, that all depends on the product that you're designing, what your idea is for a customer for a product. So let's say for an airplane, you'll have a very specific user group of customers that fly airplanes, as an example. So then you may not be able to address the exact user community or procurement community. Maybe like a big airplane, it's United or Southwest. Those are the people that are purchasing those planes. And you may be able to talk to them directly or you may not. If you're a startup company, you may not have a relationship with those companies.
Right.
So then you reach out to maybe some user communities. There may be a pilots association, or there may be other communities that you can talk to that have similar experiences, that can have some ideas to what those communities are willing to pay.
Okay.
And so you will reach out to a surrogate, if you will, instead of talking directly to like a United Airlines. You may reach out to the Pilots Association, or you may reach out to a union organization that can help you with that. Or you may find people within smaller companies like a JetBlue or some smaller, like I'm blanking out now, the air taxi markets, where they're more willing and more accessible to you to be able to get some ideas what they're willing to pay. But it's important to establish a relationship with a direct customer or a surrogate customer that can give you some insight into their thinking, both from a requirement standpoint, and then the cost of the product should be treated just like any other requirement that you have. So I like to think of cost as a technical performance measure that I would put on. So when you think about the product of an aircraft, the weight is one of the most critical aspects of the aircraft.
Right.
If it's too heavy, it's not going to fly, right? So the engines have to be able to be strong enough to propel the aircraft enough to give it enough lift over the weight of the aircraft. So weight is a huge element of the cost, or the weight, huge element in the performance of the aircraft. Sure. And every manufacturer will track weight at a very detailed level. And cost should be treated exactly the same way. So we will often break down the weight of the aircraft all to its subcomponents. We'll say the wing's going to weigh this much, the fuselage, the tail, the engines, they all weigh. They get allocated a certain amount of weight. We need to allocate cost appropriately to them as well.
How much it would cost to make the wing, how much it would cost to, okay.
Right, and then also the other elements, how much will it cost to maintain the wing?
Sure.
How much will it cost to support it, or even disposal costs, maybe something you have to address as well. If there's something hazardous in the wing that needs to be disposed of properly, you want to address that as well.
So you mentioned that affordability in the past has been more of an afterthought for some companies. To me, it seems like in the way you're describing it, seems like a very fundamental thing to consider. Why do you think it was less important, if you will, in the past? Why do you think companies thought that way?
It was hard.
Yeah.
Because designers, they understand how to compute weight. It's very easy. It's just the density times the volume, right? Or the shape that you have. So it's relatively straightforward to compute a weight of a product.
Sure.
Or a design. And so we would compute the weight. But cost, how do you assess the cost of your product? As it's all tied into the manufacturing process that you're going to use. It's tied into the rates, the labor rates that you might have, and where you're going to produce those. That all was someone else's responsibility to do.
Sure.
And so they left it up to the accountants to figure that out. And it was not as part of the design process at all.
Because an accountant's not gonna know how much of a material you're gonna need
Right.
or something, unless you tell them, but you would have to,
It's a very involved process.
sure.
So I had the pleasure in my career of helping create some tools for, and so I have one company that I was at. I came out of the design world as a design engineer, and I was asked to lead a team to develop a tool that we could, with the push of a button in our CAD model, be able to predict the cost of the product itself. And so while the designer was designing his product, he could answer a few simple questions like, what kind of part is this? What kind of material am I using? And what manufacturing process do you envision being used for this? And by knowing that, we developed a tool that would automatically recognize the critical features of the design. So if you're machining something, it would identify all the pockets that would have to be machined out of the metal, what corner radiuses that were being used, which would drive the tools that were being selected. It would recognize all of that automatically. It would compute the time that it would take to machine the part and apply industrial engineering standards that would then compute the cost and provide to the engineer a Pareto diagram. So it would tell them, here's the most expensive feature that you have on your design, and give a diagram of every feature and the cost associated with each of those features.
Wow.
And so that way the designer now had the tools that he could say, oh, I did not need that type of a corner radius on that, in that pocket. I can simply increase the corner radius, change the tool, it can be machined out a lot faster. I didn't realize that was driving the cost of my design, and significantly reduce the cost of his design in the process.
That sounds incredibly crucial.
It was, what was interesting was when we started out in the process, I got told by a number of people that don't take that job. It's impossible, no one can do it, it's never been done before.
Yeah.
It cannot happen, it's,
You don't tell Dave that.
you're gonna ruin your career by doing this.
Yes.
You're right, you don't tell me
You
that.
don't tell
sort of-
Dave that. You said challenge accepted.
In fact, that's exactly what happened. Because I actually didn't want the job. I was asked to do that, and they interviewed, I think it was 10 different engineers or managers to do this job. And in the end, they offered the job to me, and I was going to say no until one of my co-workers, who also interviewed for the same job, and I respected him highly, he's a very, very smart individual. He told me, oh, you can't, that's an impossible job, don't take that job.
Is that part of why you were going to say no, was because of the work it would take, or because you doubted the ability of it?
I didn't see it in my career path.
Okay. So you knew you could do it, you just didn't.
I felt it could be done.
Okay.
I saw a way that it could be done.
Okay.
It wasn't really in line with my passion.
Sure.
And it took me outside into a role that would be a functional role rather than on a program role.
Got
And
it.
I really enjoyed touching the product and being part of the
Hands-on.
product. And when he told me, Doug told me that it couldn't be done, I was like, no, you're wrong. And he said, no, it's impossible. So that just incentivized me to prove him wrong. And I also realized, but they twisted my arm. I had to be convinced by my management that this was an important task for me. They actually told me that they didn't think anybody that they had interviewed was capable of pulling it off.
Wow.
And I was the one that convinced them that it could be, and why they wanted me to do it. So
Excellent. That's excellent.
Maybe I got stuck in that job. I had to force my way out of it, actually.
Well.
But we were successful. We did accomplish that. We demonstrated that it could be done, and blew the people's socks off, literally, with it. So
That's incredible.
it was a way of defining, giving power to the designers so that they could know. every manufacturing process that we knew about at the time, whether it was a composite buildup, machining, an assembly process, all of those, we defined all of those processes. We built the cost models and built the algorithms that would automatically recognize those features in the CAD model. So, and linked it to the solid models in the CAD system. So it was a fun project. Took about 5 years of my life. So
I feel like something like that would be very worth it, even though it's probably not. It wasn't probably very stimulating for you, but I just that's incredible. It kind of seems like something that every body should have
yeah, I think it was an important tool.
to optimize.
It cost a lot of the company's time. But it was an innovative approach to how we solved the problem, and it really gave the power to the engineers to understand what the costs really were.
Yeah.
And when you could provide it in that way to the design teams, they got really excited because they could see, oh, now I understand the cost, where before they didn't. So one example that we had was we took an assembly process, and the design teams were putting the assembly drawings together, and we took those CAD models and interpreted them.
What is a CAD model?
Computer-aided design. So basically today the way designs are developed is they develop them in 3 dimensions. And so then the assembly of them you take the different components, you assemble them into the CAD model, and that creates the entire aircraft, if you will, by putting everything together in one solid model. But each piece is its own individual solid model. And so we took the assembly version and assembled it and computed the cost and created the Pareto diagram. And for this one particular company on this one particular part, the number one process that was costing the most, which was a surprise to them, was shimming. And
What is that?
shimming is when you put, an airplane has to be put together to some very tight tolerances.
Right.
And when in fact the interfaces between the parts can be so tight that, because they have to fit very snugly together in order to hold together and carry all the loads, that the manufacturing tolerances to make those effectively can't be as tight as what you actually require. So you wind up designing in spaces between the two to absorb those tolerances,
Okay.
if you will. So when you made up these surfaces, you wind up having a gap between them, which you can't have. So to pick up that gap, you shim. You put a piece of metal or some sort of material in between to fill that gap and create a very tight fit.
Okay.
But shimming is always it's an unknown. So sometimes you'll have a peelable shim. You'll have a piece of material that is extra thick,
Okay.
and then you can peel off to the exact thickness of the gap that you have. And so other cases you have something called liquid shim, which is a liquid that you'll pour in between and it hardens to fill that gap as much as possible.
And for this example, what type were they using?
They were using metallic shims,
Okay.
which was that peelable kind, but it was so that process, you pick a certain size, you go measure and say, okay, I need to peel off this much, and then you put it in place.
And so why did it cost? Why did it cost so much, and why was it a surprise?
It was a surprise because it was a standard practice, and they didn't realize how much the cost of the process of shimming. It takes a person a long time to then measure the gap. It's not just install it, slip it in, and clamp it down.
Sure.
You have to go measure the thickness, then you start peeling, and it's a rather time-consuming process.
Okay.
And so it was used extensively everywhere. So what they realized was what they were doing in the design process was allowing the manufacturing process to get the cost of each detailed part down as low as possible. They were allowing the tolerances to be bigger. And as a result, the gaps were becoming bigger, and we were requiring to use more shims. And the shim cost was becoming very prohibitive at that point. It's the number one cost of the entire design. So they were transferring all of the cost of the detail cost of the parts into the cost of the assembly and driving that into the shims. So they took about a secondary process of, okay, how can we drive the cost of the shims down? If we increase the tolerances just a little bit, so that we no longer have to shim, but now can have and it's by using geometric tolerancing and adjusting the tolerances in a way that would allow us to have a snug fit, but still not one that was impossible to mate up. We can now, it'd be a slightly higher cost, but much less costly than the cost of the shims.
Wow.
So they were able to eliminate the majority, almost 90% of their shims got eliminated, and the cost of the detail parts rose a little bit, but the overall cost of the entire design went down.
That's very cool.
So
It seems like giving that information to the design team can really benefit a company, because if they're aware that this is happening, these are, engineers. They're design. I mean, they solve problems. They
exactly.
Yeah.
They want to
So
solve
it's
a
like,
problem.
to me, it's a no-brainer to give them that information, because it's like, okay, well, yeah, we can challenge accepted. We'll figure out a way to get the cost down. So
If you can give them a tool that helps them understand what the drivers are for the cost.
right.
If you just say it's costing too much, that doesn't help them any, because they don't know where to attack the problem.
Right.
So by giving them a tool that understood the feature-based design cost, so they understood the features of the design, what was driving those features, and as a result what was driving the cost of the product, that gave them a tool for them to be able to understand, how can I affect the cost of my design.
That just seems so vital to me, especially for startup companies or anybody. It just seems like such an important thing to know and information to have.
It can be, but the tools can be expensive to develop, and this particular tool was specifically designed around a specific company's processes.
Okay.
So you have to understand your labor cost, you have to understand what your industrial engineering standards are relative to those processes that you're using. Those all take time to develop and to build, and it can be expensive to fabricate those.
Okay.
So it was an important tool, a very necessary tool, I agree with you, but it was costly to develop and to build for the company.
Okay.
So for a startup company, you need to, while you want to move in that direction, you may not have all that information at your fingertips. So the way I would like to approach it with companies is, then you take surrogate information to give you relative cost. So you can design around that. So maybe you don't have the standards for your company, so use somebody else's company and somebody else's standards as a surrogate that you will improve on as you evolve. But at least you now know, relative to these other features, these would be cheaper to build than the other ones. You may not know the exact cost. We actually, in this company, we actually validated the cost and the cost models against what was actually being built and against the standards we were using. And so because of that, the accounting firms validated our models in a way that allowed us to use it for pricing exercises, not just for relative reduction of term or reduction of cost, but as an actual pricing model we could actually then bid to our customers.
Wow.
And we could do that in advance of even building one part.
Wow.
So it was very powerful. Once we had validated the models against how we were producing them, we could do that.
That's very, very awesome. Okay. So can you think of any other examples, or how else is affordability useful and a good thing to consider?
Well, affordability, understanding the cost of your product and relative to what the customer is willing to pay, helps you assess the risk of the product as well.
Right.
So it ties back into risk management and the trade-offs that you do. And so as you're looking at design trade-offs and the risks that you have, cost is an important variable in that, and truly understanding the cost of your product and what it's going to take to either design and to build and then to sell to your customer are important aspects of understanding those trades.
Yeah.
So without understanding the cost elements, we're actually probably missing the most important element of the trade-offs that we're making.
Sure.
And so being able to take affordability, integrate it with our design process in a way that makes sense, in a way that's meaningful to make important decisions, allows us to make effective trades and to understand the risks of our product and the risk of our development. So it ties back in many ways into the other processes that we've talked about, into customer contact, into the risk and opportunity management, ties back into issue and action management, all of those things that we do into our scheduling. It's an integral part of the overall process of program management. And while it's kind of a latecomer to the game of actual management practice, it's a crucial one into managing the overall elements of our program management.
Absolutely. All right. Well, thank you so much for that information. If anybody else has any other questions, go ahead and go to collaborativeconsultants.net.
Thank you.